Greetings and welcome to the strip. So now that you know a few basic operations in Python and you can do perform basic calculations in Python, now we move on to the next step in programming, that is the use of conditional statements. Conditional statements are very useful in programming when you are given a certain condition, and if that condition is satisfied, then a certain part of the code should be executed. Otherwise, some other part of the code should get executed, right? For example, if say you have, from a chemical engineering point of view, let's say you have to distinguish between a laminar and turbulent flow. So for a pipe flow, say if Reynolds number is less than 2100, then it's a laminar flow. And if it is greater than 4000, then it's a turbulent flow. So let's say you want to calculate some transport coefficients for a particular flow, right? So in that case, you'll first of all calculate the Reynolds number. And if Reynolds number is less than 2100, you will follow a certain set of equations. And if it is greater than 4000, then you'll follow another set of equations, right? So to execute such a problem, you need what we call are the conditional statements in program. All right. So in Python, the conditional statements are if else statements. All right. So let's start with the syntax for if statement, and then we'll move on to solving basic problems using these conditional statements. All right. So let's say if you have to use the if statement. So as I mentioned, to use a conditional statement, you must have a certain condition. Okay. So let's say I have a problem. Okay, if x is equal to 2. All right. I say that x is equal to 2. And now I want to print the value of x if it is less than 3. Otherwise, I don't want to print it. All right. I want to print the value of x if it is less than 3. Otherwise, I don't want to print. So what should I do? I should just use the if statement over here. So I'll say if. Now, what is the condition? That the value of x should be less than. So if the value of x is less than 3, then I need to print the value of x. Otherwise, I don't want to do anything, right? So now if I run this code, then you will see that the value of x gets printed because this statement, x less than 3, is actually true. But let's say this statement was false. Let's say the value of x is 10. So in that case, nothing would happen. In that case, nothing would happen, right? Now, you might have noticed that after the condition, I have put a colon over here. And before this print, I have actually left some space, right? So these things are actually some common Python syntax. All right. So in if statement, else statement, or further when you will be using loops, so there, the colon is actually very important. So the colon signifies that anything after this colon has been put, and after so anything that is written at a particular indent, as in a particular space from the margin, all of it should be executed if you are moving inside the colon. Moving inside the colon as in the condition being true. So for example, if this condition is true, x less than 3, then our entire program would run inside the colon. And running inside the colon means every statement which is indented. So for example, if I give print x, then after that I give print x plus 1, print x plus 2, print x plus 3, all these statements, then all of these will get executed if this condition is true. All right. And then let's say, as you see, I have removed the indent now. And now I give some statement, say print x plus 10. So in that case, what would happen actually, that if this condition is true, then only these will get executed. But if this condition is false, these won't get executed. The statement that is unindented, that would get executed irrespective of the condition. Whether the condition is satisfied or not, if the this particular print statement that is written outside the if as in indented towards the margin. All right. If it is written over here, that means this will get executed irrespective of the condition. The condition does not affect the execution of this state, right? So you'll see as I run this code that whether or not the condition is satisfied, this will always get executed. This statement always gets executed. So over here, as you see, the condition is false. So none of these four statements got executed. Only this statement got executed. But let's say I change the condition. So now this condition has become true. So you will see these four as well as this, all of them would get executed. So now as you see, you've got these four as well as the statement outside the. So as you see, both the times, whether the condition was true or whether the condition was false, the statement outside the indent was always executed. All right. So if you want to keep any statement inside the if, you'll need to put the indent. All right. Now let's say you have to indent a particular statement. Let's say you've written some statement by mistake. Let's say you've come out of the indent and you wrote these uh, these two statements which are out of indent, but you want them to be inside. So what you can do is you can just select these two, go to format, and you can say indent region. So that would automatically adjust the indentation of this particular these two statements. All right. So that can be done using your Python IDL. All right. Now, this is the use of only if state. All right. So if x is greater than 3, then these 5 will get executed. However, this statement, print x plus 10, is getting executed always. Let's say I don't want that. All right. Let's say I don't want that. Let's say I want to print x plus 10 only and only if x greater than 3 is not satisfied. Okay. Let's say that is my purpose. So for doing that, I can use another statement, which is else. But remember, if else has to be used only after if. Okay. So what will this actually do is, if x is greater than 3, that is, if the condition is satisfied, then it will execute all statements under this. However, if x is not greater than 3, that is, if the condition is not satisfied, then it will execute all statements under else as in indented according. All right. So these statements are under if, these statements are under else. Okay. So now, based on this, let's see what happens. So as you see, now only these 5 have been printed. The x plus 10 statement did not get executed. X equal the 20, it did not get printed. Right. However, when I was writing print x plus 10 in an just close to the margin, there it was getting executed even if the condition was false. So that is the use of the else statement. All right. So let's say I make the condition false, then it will print 20. So now it has printed 20, right? So you have to keep in mind that if this is true, then these will get executed. If this is false, then the else statement would get executed, right? However, let's say I have multiple conditions. Let's say I want these four statements to get executed if x is less than 3. I want these two to get executed if x is between 3 and 7. And I want this to get executed other. So now as you see, I have multiple conditions. The first condition is that x is less than 3. Second condition is x is between 3 and 7. Third condition is that x is greater than 7, right? So for three conditions, or for more than for more than two conditions, the two conditions being, so the two conditions are always obvious, that x less than 3 and x greater than 3. That's the scenario for this problem, this code that we have written. So if more than two conditions are there, then we have to use another statement called as elif. Okay. So what we'll do is, so after if we provide the first condition, then after elif we provide the second condition. Okay. After elif we provide the second condition, and then the third condition is obvious. The one that does not lie in the first and the second category goes in the third category, right? So for example, right now I said that the third condition should be that x is greater than 3 and less than 7. So remember, in Python, you can again execute the same thing that you said. X is greater than 3 and x is less than 7. So I can just write and over here, and this would get executed, right? So x should be greater than 3 and x is less than 7. This is equivalent to saying x lies between 3 and 7. It's equivalent to saying, okay? So the and that I have written over here, this is known as a logical operator. All right. This is known as the logical operator. So let's discuss a little more about the logical operators on the shell. So for example, if I have, let's say 1 and 2, so it gives me 2. Let's say if I have 1 or 2, then it gives me 1. So what is this and or? It's a very hard thing to understand. All right. So and or, these are known as logical operators. Okay. So and would give true as an answer if the first as well as the second condition is satisfied. Or would give true as an answer if 1 or 2, either one of the two conditions is satisfied, it will give true as an answer. All right. So let's see, for example. So right now we have x equal to 10. So if I give condition 1 that x is greater than 3 and condition 2 that x is less than 7. So now both of these conditions, x greater than 3 and x less than 7, these should be satisfied. Only then we'll get true. As you see, x equals to 10. So none of these conditions are satisfied. So therefore, you'll get a false. So x less than 7 is not satisfied. Sorry. X less than 7 is not satisfied. This is satisfied. X is greater than 3. X is 10. 10 is greater than 3. So this is true. This is fine. But this is not fine. X less than 7. That is not there. So therefore, it would give false as an answer. Right? But if I use or in case of and I say that x is greater than 3 or x is less than 7. So it will see, okay, one of the two conditions is satisfied. So I'll give true as the answer. So it gives true as the answer over here. Right. So for and to give true as the answer, both conditions should be satisfied. For or, one or two, either one or both of them should be satisfied. Either this should be true or this should be true or both should be true. In either case, it's going to give you true as an answer. All right. So and or are known as Boolean operators. All right. And or are known as Boolean operators. Okay. And also false and true are also known as Boolean variables. False and true are known as Boolean variables, and or are known as Boolean operators. Boolean means true or false. Okay. So that is the condition over here. So this and means that x should be greater than 3 as well as less than 7. If both of these conditions are satisfied, only then these two will get executed. So as you see, x is definitely greater than 3, but it is not less than 7, right? So therefore, these two would not get executed. Only this would get executed because x is anyway not less than 3. X does not lie in this region as well. So it will only execute this, right? So if we run this, so it will just give me 20 as the answer. All right. Let's say I give some number that lies into the second range. Let's say 5. So now it gives me 5 plus 4 and 5 plus 5. 9 and 10 as the answers. All right. And let's say I give, let's say 2 over here. So it is going to give me the first 4 statements, 2, 3, 4, 5. All right. So you have to identify which statement to write where. Okay. That is very important. Okay. And when to use multiple conditions, when do you have more than one, when do you have more than two conditions, and everything. All right. So that is about the Boolean, sorry, the conditional conditional statements, if, elif, else. And you can have multiple elif statements. So for example, if you're not satisfied with this condition as well, you can have another statement that if x is greater than 7 and x is less than 10, then this should be printed. Then let's say print uh, 15. All right, let's say anything. So then you can have as many elif statements as you want. Okay, so that is a very nice thing to learn and work on. All right. Okay. So now that you've got a basic fundamental introduction to if, elif, else, all right, there are going to be multiple problems that we solve for getting used to getting easily familiar with uh, if, else statements. But for now, this much is fine. So now that we know what is the syntax of these statements, how do these statements work, let's move on to a very fundamental chemical engineering problem where we check whether the flow is laminar or turbulent. If the flow is laminar, we perform some calculation. Otherwise, we perform some other calculation. Okay, so let's do that. So let's open another window. And over here, we are going to see whether the flow is laminar or not. Okay, so for this particular video, I'll just write a very simple code. That code is going to print the type of flow, whether it is laminar, turbulent, or it's a transition. All right, a flow in a pipe. So this actually tells, or this code tells the type of flow, whether it is laminar, turbulent, or transition. Okay. All right. So for getting whether the flow is laminar or not, we need all uh, sorts of uh, uh, all sorts of uh, parameters to calculate the Reynolds number. So we know that Reynolds number is rho density multiplied by velocity multiplied by diameter divided by viscosity, right? Divided by the viscosity. So we'll give all of these values. So let's say rho is 1000 kg per meter cube. That's for water. Velocity is, let's say, 2 meter per second. Diameter is, let's say, 2 meters. All right. And viscosity is 10 to the power minus 3. Now, 10 to the power minus 3 Pascal seconds. Now, another thing, in Python or in any programming language in general, you can use scientific notations. Scientific notations means that when we are writing 10 to the power minus 3, all right, 10 to the power minus 3. So instead of writing this, you can use the scientific notation 1e minus 3. That is also same as 10 to the power minus 3. So let's say if you want to write 10 to the power 5, that is 1e plus 5. If you have to write 2.5 into 10 to the power 7, so that is 2.5e plus 7. All right. So that is the kind of thing. These are a few things that you can do in Python. And in general, you can do these things in any programming language. The scientific notation works, right? This is known as a scientific notation. So the viscosity is 10 to the power minus 3 Pascal seconds. All right. Now, let's identify what conditions do we have. Okay. So what are the conditions? If Reynolds number is less than 2100, then it is laminar. If it is greater than 4000, right, then it is turbulent. And in any other case, as in between 2100 and 4000, it's going to be transition. All right. Otherwise, it is going to be transition. So as you see, we have 1, 2, and 3 conditions, right? So since we have 3 conditions, so we have to use if, elif, else. All right. So before that, let's calculate the Reynolds number. Reynolds number is rho v d by mu. All right. And once this calculation is done, now we can write the conditional statements. If Reynolds number is less than 2100, colon, very important, print, it's laminar, right? Then we move out of the indent and we say elif. And then over here, we give the second condition. If the flow is greater than 4000, so print turbulent. Okay. And finally, if it's neither less than 2100 nor it's greater than 4000, that is, it lies between 2100 and 4000, we'll say that it's transition. So let's identify what kind of flow is this in the pipe. So, uh, so now if we run this program, so I'll also print the Reynolds number to see what is the Reynolds number and whether my program is working fine or not. So let's do that. And now, as you see, the Reynolds number is 40,000, right? The Reynolds number is 40,000. So this is a turbulent flow. All right. Let's say if we make the velocity 0.02, then in that case, the Reynolds number is 4,000. One second. All right, fine. It's 40,000. It was 40,000 before. One second. When it was 2, so it was 4 into 10 to the power 1, 2, 3, 4, 5, 6. 4 into 10 to the power 6. All right. So let's say we make it 2 into 10 to the power minus 4. Let's say that is the velocity. So in that case, the Reynolds number becomes 400 and now it shows it's laminar. All right. And let's say I give some value such that the Reynolds number becomes between, let's say 2100 and 4000. So let's say I give this as the value. So now, as we'll see that it's 3000, so it shows transition. So this is a simple code to find out whether the flow is laminar or not. Now, if there are some other calculations that you'll need to perform, let's say we want to perform a certain set of calculations, a certain set of formulas we need to use. If let's say it is laminar flow, then we can put all of those statements over here, as in inside this if statement. And similarly, if we want to perform a certain set of calculations for turbulent flow, then we'll put all those statements inside this elif statement. All right. So we'll do that in uh, further videos as well. All right. Now, since this was an introduction to if, elif, else, and all, and I have introduced quite many things over here. For example, the if, elif statement, then the Boolean operators. Uh, so there could be certain level of confusions. So that's why after this video as well, I have put up a self-assessment test where you can just check, you can apply whatever things I've told you in this video, and you can check if you're getting those things or not, so that you're conceptually clear as you move further and apply the conditional statements in more complex programs. All right. Also, I would be uploading a few videos where instead of lectures, I'll put them in tutorial playlist. That would be basically the application of whatever you learn in these lectures over here. So a few more chemical engineering problems. So I'll upload a tutorial video where I'll do some calculations based on laminar turbulent flows and show you people how uh, you can write such codes, such fundamental chemical engineering codes, and then we'll build on those as well. So yeah, those tutorial videos will be in a different playlist. So please do watch them. Moreover, if you're watching this video, then please do watch the other videos, the previous lectures that I have covered before this. And also I have uploaded a self-assessment one test before in the previous video. So do take that as well. That would give you some fundamental understanding of how much you've learned in the previous few lectures. So that is all for this video. Thank you.